Hello, everybody. Thank you for the presentation. I'm Kamila. I'm PhD student, and I am talking. I'm sorry. I'm really nervous, and my English is not good, not good. But today I will present a work developed by joint collaboration of the Environment Technology Group and the Faculty of Engineering of Porto, and whose title is Effect of Carbon Supplementation on Landfill Leachate Treatment in Aerobic Granular Sludge. And I am talking on behalf of my colleague Vicente Silva, also a PhD student. So, initially we know that in most parts of the world, the main method for solid waste disposal occurs in landfill. This method is of paramount importance for the preservation of the environment. However, the diversity of waste that is disposed produces a very leachate, very heterogeneous, and has a very complex composition. The treatment of landfill leachate can be carried out in a proper treatment plant located in the landfill, transported to a wastewater treatment plant for cold treatment, or even through reinjection or recycle to the landfill cell. Cold treatment is an excellent strategy to reduce cost and to provide a better practicality. However, it must be carried out in a very careful way so that the wastewater treatment plant doesn't suffer negative impact and performance is impaired. Among the main biological process used, conventional activated sludge is commonly used for leachate treatment, being the most economically efficient method for the removal of biodegradable organic compounds. However, there is a very large limitation regarding the degradation of recalcitrant organic matter and biological nitrification due to presence of large concentration of inhibitory. Thus, new strategies must be studied and optimized for the treatment to occur reach high efficiency. One of these strategies may be the use of aerobic granular sludge system, which have been extensively studied and consolidated in the treatment of simple effluent. Aerobic granular sludge is characterized by a microbial community flocal cable for carrying out in a single system almost biological conversion, gaining space by present numerous advantages such as excellent biomass servability, high retention concentration of biomass in the reactor, formation of different zones in the granules, ability to support high ascent feed velocities, less vulnerability to toxic process, no need for support material, reduction of treatment operating cost and energy demand, and decrease in area demand. Although the aerobic granular sludge system has been applied in the most diverse sector of effluent treatment, research on landfill leachate treatment and cold treatment is relatively small. Moreover, the efficiency of denitrification is usually poor. Thus, the main problems commonly reported are nitro accumulation, size, granular instability and disintegration problem, loss of biomass and biomass formation time. Thus, this works so to optimize the nitrogen remove process in AJS system by increase the carbon source in the influent leachate, hoping that the complete denitrification process could reach a higher rate, generating less NOx byproducts. For this, therefore, this work sought to evaluate the cold treatment with 10% leachate with supplemented with methanol, and the granulation was with synthetic domestic effluent, and the cold treatment was with gradual addition of leachate, starting 5% and reaching 10%. All of this considered period 1, and the period 2, it's the moment and the supplementation with methanol actually happened. And the leachate use was from a leachate treatment station located in a sanitary landfill in a city port of Portugal. For this, a sequential reactor was used with oxygen, temperature, and pH control. The entire operation was automated through a programmable logical controller. The operation took place for 138 consecutive days, and each cycle lasts 12 hours. The cycle was divided into feeding reaction phase that intercalate aerobic, anoxic, and aerobic phase, the sedimentation and dispose. Discarding took place with a 50% volumetric extent. To analyze the results of organic matter supplementation with the reactor, we performed analysis of the physical characteristics of the biomass and the reactor performed. With regard to physical characteristics of the biomass, the addition of organic matter improved the characteristics of our granules that were already received 10% of leachate. From the graph of solids, you can see that from the 89, the concentration was dropped. Is this first? This happened because at this moment of the experiment, the cold treatment with 10% of leachate was started. From the 119, we start supplementation with methanol, and after the supplementation, you could clearly see that the supplementation with the development of biomass was favored, and the retention of biomass increased. This biomass development was also reflecting the growth of the granules, as you can see in the second graphic. The supplementation, in addition to increase the diameter of granules, brought more stability to the system. Linked to the growth of the granules in the performance of the reactor in the term of carbon and nitrogen removal, as the organic matter load increased, it was expected that the removal would decrease a little, what actually happened. However, in addition to the removal having shown a slight drop, the consumption of organic matter was slow throughout the cycle, as can be seen in the continuous black line of the two graphics. Prior to supplementation, approximately 3 hours into the cycle, the cod concentration had already been reduced by around 90% of remained stable for the remainder, 90% of the cycle. With the supplementation, the organic matter was available for a long time and only reaching the removal is stability after several hours of the beginning of the cycle. This was advantage for nitrogen removal because of the denitrification process to take place. Organic matter is needed, so the nitrification reached higher rates. We can state the co-treatment with high concentration of landfill without compromising the efficiency of the wastewater treatment plant is only advantageous if it has supplementation of organic matter, which in addition to maintain the quality of the system will bring benefit to improve. In addition, it's fundamental that order studies be developed so that granulation protocol for this type of effluent are established in order to produce more resistant and larger granules. We would like to thank the following institution, and for more information, please contact my colleague in this email. Thank you for your attention.